This is Dr. Carroll, and this video is about namespaces. To put this topic into context, there are 4 scope levels. There's local, for example, inside of a block. There's a class scope where members are bound to a specific class or struct. And then there's global, and it's, well, global. And then there's today's topic, which is the namespace scoping. Okay? So code is generally organized into logical units. And like an organization or company, it's divided into departments, for an analogy. The larger the project or company, the more important namespaces or modularization is needed. So let's talk about the syntax for namespaces. So the syntax is you have the keyword namespace here, and then you have what you choose as the namespace identifier, and in there you could have one or more of the following of constants, you could have variables, you could have functions, and they're within that namespace. Now once you've defined that in some file that has that your code has access to, then to use it you would specify the namespace identifier here that you've chosen, 2 colons, which is the namespace resolution operator, and then the member name, whether it be a constant, a variable, or a function. Let's see an example. Here we have a namespace. So here we have in this example, a very simple example, we have the namespace sloppy, which all it has is a constant double named pi, and it's just 3.1. We have another namespace with the identifiers being precise, also has a constant double, also named pi, and it has a few more digits there. So then in our main, we have sloppy scope resolution operator pi. So, and as Visual Studio is pointing out here, it tells you what that value is. So here's the namespace sloppy, scope resolution operator, so we know which pi we're referring to, and here is precise scope resolution operator pi. Let's run it, and here we have 3.1 and 3.14159, which is the default of 5 digits of precision. And there we have our first example. Notice how we used pi here without having an instantiation of any object. We can just refer to it, but we can specify which one we want to have here. And so when would we use, let me pull this up here, when would we use namespaces? Certainly when you have the same function name, but you need it in different namespaces, so that you can say I need this namespace or I need that one, so you don't have a collision. Let's look at another example here. The classic hello world, but notice we don't have the using namespace standard. So right off the bat you notice those red squiggles on cout, and it says identifier cout is not defined. Well, what we can do is we can say, well, cout isn't in this namespace, but it is in the standard namespace. Now you've probably typed that or seen that before, and what it's saying is this is the name of a namespace, the standard namespace, and then here's the scope resolution operator, and yep, there it is, standard. There's an OStream standard namespace on top of that, and then cout, we're good to go. Oh shoot, more red squiggles. It says this one's undefined as well. Turns out this one is in the standard namespace as well. And if you look here, look what is defined in the standard namespace. There is a lot of functions, variables defined in the standard namespace, which is why we have namespaces, so we don't have a collision of those names. Now, here we go. You can see that it's going to build, and then it's going to run, and it's going to print out hello world. There we go, hello world. Okay, now alternatively we could have put using namespace standard here, and it would have worked as well. And what that does is that's going to pull in everything from that namespace, and so then we do not need to specify. It's redundant, but it's possible, as you saw before, but it's redundant. And so we can do it that way. Okay? That's our second example there. And so the way namespaces work is if you had, for example, the function ABS for absolute value, in math.h, somewhere in there, there's going to be some code that looks like this. There'll be namespace, and it'll say standard. And it'll say, hey, in the standard namespace, I'm going to define the following. And it'll have some function where it's going to take an int and it's going to return an int, and there'll be a lot more in there. But so in math.h, it's going to have some syntax like this. And so when you include math.h, you need to specify the namespace in addition to just including that header. So let me give you another analogy. Back when I was growing up, there's a lot fewer people in the world, and consequently names were simplified. For example, one would be called Tom of Wellington, where Tom lived in Wellington, Wellington being the name of the town. Well, now when Tom is in Wellington, they don't go around saying Tom of Wellington because it's clear which Tom we're talking about. And so you have that local perspective, you just use the first identifier. But when you're outside of Wellington, you need to specify, oh, this is Tom of Wellington, so it's understood which Tom you're referring to. You could think of Wellington, for example, as a namespace identifier. And there could be other Toms in the world, but only in other towns or namespaces. Additionally, there can only be one Tom in Wellington for that name to work, so that you wouldn't have a collision. So hopefully that's an example that helps to illustrate the point for you. Now let's talk about using directives and using declarations. So a directive example would be like using namespace standard, okay, with a semicolon at the end. And so using is a keyword, or it's the using directive, and then you have the namespace keyword, and then you specify the name of it. And these can be local, for example, if they're within a curly bracket block, or they could actually have a global scope, which is how you've probably typically seen it. Now that's a directive. Now let's talk about a using declaration. So instead of pulling in all of the member variables and functions in there, you could specify exactly what you want. You could say, hey, I've included the header file for this, but the only thing I want out of standard is the ABS function. Or more commonly, you could say, all I need is the cout method, or this cout member in the standard namespace. And then that way, it's a lot cleaner. And that's how I'd encourage you to write your programs. You're going to see the using directive, using namespace standard in examples, and that's just to keep the focus on the relevant material. Although you need to avoid using namespace standard in header files so that when other files include those, they're not forced to have that namespace and potentially have that name collision. That's it for this video.